Welcome to the Theory of Vibration lecture series. Today we are going to see the basic definitions of vibration. So let us start with the periodic motion. The motion which repeats equal interval of time from the mean position is called periodic motion. Let us take a simple sine wave of the motion. This is the oscillating of pendulum of L length, stiffness K, mass M. It is oscillating to and fro, which will repeat equal interval of time. Every equal interval of time, let us take this is the time one. This is time two. Every equal of time, the motion will be repeat itself. It is called periodic motion. So next, what is the time interval? The motion is taken to complete, it's called the time interval. So the amount of time taken to complete one cycle is called frequency. So frequency is equal to 1 by t, or we call it as the amount of wave that's repetitive equal interval of time. So next we'll see the what is the amplitude. The motion which takes the maximum displacement. This is the maximum displacement. So if you disturb the pendulum, it will go this and this direction. So this is the displacement of the pendulum movement. So it will repeat the cyclic motion, the periodic motion. It will repeat equal number of time. So the time to complete one's complete cycle, this is one cycle. So to complete cycle which take a time, that is called frequency. So whereas the maximum displacement, which is called as amplitude. What is the natural frequency? It is coming to the natural frequency. In a free vibration, the amount of cyclic waves or the periodic motion take place in any system, it is called the natural frequency. Let us say it is having finite natural frequency, infinite of natural frequency. So the frequency varies depends upon this structure. So let us say cantilever beam. If you disturb this cantilever beam of length L and having some mass of the system at the end, so this is M. If it is initially disturbed, not forced vibration, if it is initially disturbed, this natural frequency will be infinite. Modes of vibration, the system which is having the lowest natural frequency, lowest natural frequency is called fundamental modes of vibration. So any system which is have at least minimum natural frequency, in this system which is having very low frequency, that is called fundamental modes of vibration. Next, coming to the degree of freedom for any system. Let us take spring mass system. This is a spring mass system. If the motion of the system is in one direction, this is 1 degree of freedom. Let us take one more system, mass having two spring, K1 and K2, K1 and K2. So the system can linearly movement or rotational movement. So this system is having 2 degree of freedom. So already we discussed about the cantilever beam. Cantilever beam load which is having infinity degree of freedom. So it means number of independent coordinates required to specify the motion of the system is called degree of freedom. For any spring mass damping system or spring mass system, that depends upon the movement of the mechanical system or the system. It's called degree of freedom. Next, we will discuss discuss about the simple harmonic motion. Simple harmonic motion. SHM. So let us say again we take the pendulum, which is oscillating to and fro. So it will create a sine wave of amplitude A. So we can write the displacement of the system will be x equal to A sine omega t. So now we can get the acceleration, that is x dot equal to A cross omega t. The omega will come here. Again, below t will come here. Again, we can rewrite this as x double dot. We can rewrite this as A square omega. So x double dot. So we can write this as A omega square sin theta. So again we can write it as x double dot equal to A omega square. This A sin omega t we can write it as x. So acceleration is directly proportional to the displacement. So in a simple harmonic motion, it is a periodic in nature. It is a periodic in nature, and it is directly proportional to the displacement. That is called simple harmonic motion. Next, coming to the phase difference. If the system is having two or more displacement, let us take spring with two masses. This is a mass 1, this is a mass 2, this is a 1 stiffness. Let us say this is a train compartment, two different compartments. So in a initial experimentation, it may go this way or this way, or opposite direction. It will go this way or this will move in this direction. So these two compartments will have two different motions. So for this we can write the displacement equation A sine omega t, and we can write the phase difference is equal to A sine omega t plus phi. We can write this in a sine conversion. Let us take the first element movement, and the second element will go either here or here. So it will start the motion. These two amplitudes are same, the motion, the repeating motions are same, whereas the phase only differs. These two waves will not start in the same way. So this is called phase difference. Right? Next, coming to the resonance. Next definition is resonance. For any system, it is having its own natural frequency. Let us take a string mass system. If this system is having a natural frequency of Fn, and external excitation by applying any disturbance, if this two frequency get matches, means this system will get more amplification or more amplitude. That time the system gets resonance or get critical condition. When the natural frequency of the system is matches with the actual frequency, then the system gets maximum amplitude. The amplitude of the system will get maximum A max. That is called a resonance. That is a critical condition of the system.